Welcome to the Daily Space Weather, folks. Today we're looking at climate, the AMOC, and at cosmic rays. Before we get into any of that, let's look at the sun. Here it is at 193 angstroms. Coronal hole there in the south. No sunspots. Pretty low activity, although the solar wind has kicked up a little bit. Here's a view in 304 angstroms. And you see some active regions setting there on the west. Again, no sunspots. Let's zoom in a little bit. There's the north portion. Large filament setting there over the northwest. And here's the south. And we're looking at a little over 8 hours of activity here on Wednesday, January 15th, 2020. How's your vision? Is it clear? Now, we're looking at the Space Weather Enthusiast dashboard here. The Space Weather Prediction Center forecast. And I really don't know what they're forecasting here. I just figured I would show it to you, as we appear to have just entered a coronal hole wind stream. I'll just let that play through for you there. I just wanted to show you that real quick. Not exactly sure what they're predicting there, but in any case, if you want to look at it yourself, check out the Space Weather Enthusiast dashboard. X-ray flux is quite flatlined here. Nothing in the B-class range. Not a surprise there with no sunspots. 10.7 centimeter radio flux still at 72. Basically solar minimum conditions here, although we saw it as low as 64 just a couple of months ago. And the KP index is back down to 0, having been only 1 or 0 for the past 3+ days. And we're going to get to some cosmic ray monitors in a minute. First, let's look at the real-time solar wind. And we just saw a shifting phi angle here as I did the show prep. We saw a short-lived magnetic connection with that coronal hole there, right at the same time that the solar wind density and speed increase at the same time. So you can see solar wind density kicked up here around 1847 universal time. And then it continued to rise. You see the scale has expanded here. We saw some readings as high as over 100 protons per cubic centimeter there. Anyway, the current solar wind density at 2.28. Phi angle is shifting around. BZ is highly negative here. Negative 4.7 on the BZ, and the total field is at around 5 right now. Again, solar wind density 2.28 protons per cubic centimeter, solar wind speed 332. And we would expect to see this rise a little bit here. It looks like a pretty weak coronal hole wind stream. And there is the data from ACE. And you can see some very sporadic readings there, especially on the solar wind density there as well, having come up off of the floor below 1 proton per cubic centimeter throughout the end of the day yesterday. Relativistic electrons have finally leveled out there. Haven't reached very high levels, they're just in moderate levels, and we're expecting to see those drop, as well as the GOES electron flux, and we're going to see this drop throughout the day, and this will rise back up in about 48 hours to a more normal level following the coronal hole wind stream. Here's the ionosphere movie, and we show this each day to show what's going on in the ionosphere, right? So here we have some anomalies in the south, as we've been seeing along the prime meridian, and those look like some kind of measuring errors there. And we see a fairly discharged ionosphere here on the sun-facing side, and those South Pacific anomalies continue off of the west coast of South America around the 30 degrees latitude by 120 degrees longitude area around where my pointer is. And the GOES magnetometers are expected to be a little more smooth in the coming days, as we are solidly in the South Pole-oriented portion of the heliospheric current sheet right now. And we crossed over there right around when we did the show yesterday. Here's the Gong 2 data. Keep in mind this is quite old this time. It's 3 hours and 25 minutes old. Let me just see if there's a newer data set here. And nope, that's the newest data set. 3 hours and 48 minutes old, folks. And there you can see the Earth's field force line snaps into the South Pole-oriented portion of the current sheet, shown here in red. For you new viewers out there, the poloidal fields, the fields coming out of the solar poles, charge up the current sheet. And this is the North Pole portion here. That's the North Pole polarity, shown in green. South Pole polarity is shown in red. And we've seen the South Pole running the show here for quite a long time during this solar minimum. Here's where objects are in the solar system. There's where they'll be in 1 week as Venus is coming around to make a visit on this lonely side of the sun, where all of the planets are on the other side of the local yellow dwarf. Here's where stuff is above my head. This is in-the-sky.org, by the way, if you want to make your own sky chart. Where were you when Deneb rose? We're going to talk about cosmic rays in a minute. By the way, Mars should be rising soon. And there is Mars coming over the horizon. It'll do so around 5:20. And I'm located in the Lehigh Valley, if you're wondering, folks. Here's the Geospace Magnetosphere movie, looking at the magnetohydrodynamic pressure. And if you want to watch yesterday's space weather video, we saw the weakest geospace magnetosphere that we've seen ever on the channel. And it has kicked back up here into more normal ranges. Although I would note that the size of the plasmasphere and the size of the inner Van Allen belt is quite large, having spent the end of the day yesterday with a very, very low proton count. I'm just going to let this play through a second time today before we move on to the geospace ground magnetic perturbations. And here's that. Nothing too exciting going on there during this polar excursion, while we have 2 North Poles, the net of which is somewhere east of Greenland, and our South Pole appears to be creeping into the southern Indian Ocean. Please leave a comment if you have theories as to how the Earth's geomagnetic fields are generated. Next, we'll do earthquakes, and it looks like we saw some come in as I did show prep once again, folks. And we've seen regular instances of data sets coming in that I'm not prepared for as they happen while I make the show. So, first of all, we see a deep quake here at a 4.2 magnitude in Argentina. That one coming in at 10:41 UT yesterday, right around when we made yesterday's daily space weather video. And I'm just going to scroll up the list here. Puerto Rico gets another 4.6 as aftershocks strike again and again. It looks like the largest quake of the past 24 may have just struck in Mexico, but let's just take our time getting up the list here. Another deep quake strikes Colombia in northern South America there. That one at 162 kilometers depth. Very deep quake strikes near Fiji. That 5.3 magnitude quake at 511 kilometers depth. Here's a deep quake in the Caribbean as a 140 kilometer 4.8 magnitude quake strikes Dominica. Here's a deep quake at the Philippines as they've seen an uptick in volcanic activity there. And here we see a 5.5 coming in Indonesia. The largest quake of the past 24 happened just a little while ago, folks. And let's move on to some more data sets here. Let's look at cosmic rays real quick. We're going to look at 3 monitors today. First, Athens. And there's the Athens neutron monitor. Pretty flat over the past 30 days. Next, we'll look at Mexico City. And there's the data there. Also pretty flat over the past 30. Showing a pretty decent spike there on January 3rd and 4th. And next we'll look at Oulu and DOMC Antarctica. There's Oulu, Finland. Showing a similar spike on the 3rd and 4th, by the way. And there's DOMC Antarctica. DOMB Antarctica not sending data. And let's talk about a new cosmic ray balloon, which is just going back into service. This has broken some records for Antarctic aerial cosmic ray detection. And I've thrown coffee once again today. I don't know why I always throw coffee, but I've done it again. So check this article out about the balloon-based cosmic ray observatory, now on its 2nd trip around Antarctica. It's the Super Tiger. Anyway, read about that if you like. As cosmic rays are becoming a more and more important aspect of things like climate science for those of us who actually understand atmospheric physics. Now let's talk about some total nonsense. Thanks to clouds, new climate simulations predict more warming than predecessors. Basically, that's because climate models are predicting more warming no matter what the situation is, whether it's a thing that increases the Earth's albedo and reflects more energy into space like clouds is another story. They don't care. They're going to figure out ways to make clouds make the planet warmer. So while clouds do make the planet warmer at nighttime, they make it colder in the daytime due to the albedo effect and the greenhouse effect. That is, in the daytime, clouds reflect light back into space, and at nighttime, clouds act like a blanket via the greenhouse effect, and they hold warm air in. Have you ever noticed on cloudy nights it tends to be warmer? Well, increased cosmic ray flux makes colder days and warmer nights. That's just the way it is. And clouds do not lead to global warming. Clouds are a global cooling factor, and they are associated with cosmic ray flux, which is also associated with a cold thermosphere and solar minimum. Links to that article shall be below the video. Let's talk about the AMOC, the Atlantic Meridional Overturning Circulation. If you're not familiar with it, read the Wikipedia article. It's very important about the way the Gulf Stream heats up places like the UK. And ultimately, what happens, folks, is that if the globe gets warm enough and Greenland melts, which it isn't doing, by the way, that global warming causes global colding because of the shutting down of the AMOC will cause colder and drier conditions in the UK, which will spread around the entire northern hemisphere. That is, the AMOC is a negative feedback mechanism. Let's talk about it via this article. It could cut British crop farming, yes. And I just like to state that a colder planet is a danger, not a warmer one. A warmer planet would lead to easier farming. Siberia would become a massive farmland. Not to mention Australia would probably get better weather as well. Perhaps Australia would go back to being a net exporter of grains instead of a net importer of grains like it is now, as we see all kinds of global level crop losses. Over 25% of the pig population of the planet has already died as a result of this new African swine flu. So in any case, a little bit of warming would be good for mankind, and a little bit of colding would kill billions of people. I'm talking 1 degree C or 2 degrees C colder could cause global level catastrophes. And we are already seeing ridiculous weather all around. And if you think it's caused by CO2, I certainly feel sorry for you. Anyway, that article linked below the video as well. Let's look at the pressure maps on windy.com, and we're going to let this advance via the GFS forecast. It's currently 3:52 while we make the video. Do you know where your pressure zones are? And we'll let this advance to about 12 o'clock Zulu tomorrow. And there's where we expect pressure zones to be at noon Universal Time, aka Greenwich Mean Time, or Zulu, whatever you like to call it. That's where we expect stuff to be. And today's volcano list includes Mount Aso, producing a 6,000-foot ash plume, Sakurajima, 6,000-foot ash plume there, Mount Tall, 3,000-foot ash plume. Let's hope it doesn't cause huge death and destruction. The Tall volcano now on the list. Krakatoa back on the list, producing a 1,000-foot ash plume as it explodes. Another scary volcano. Mount Dacono exploding. Flight level 7,000 there. Fuego, not sure if it's emitting or not, as it's probably cloudy on the satellite image. Revenador exploding. 16,000-foot ash plume there. Unable to detect whether or not Sabancaya is erupting. Please do not attempt to pole vault the Sabancaya caldera. Here's where lightning is, and we like to use lightningmaps.org. Do you have a better real-time lightning monitoring site? Perhaps head to smashomash.com/forum and tell us all about it. Here's where the jet streams are in the Western world. And let's rotate it around to the Eastern world. And there are the jet streams over there, looking a little more organized on that side of the planet, at least than they've been in the last couple weeks, as we see extreme meridional jet stream flow. And here's the U.S. Doppler radar map, as snow continues to fall in places like North Dakota and Minnesota. Pretty nasty looking ice storm over Iowa. Shout out Aubrey and other Iowan viewers. Looks like some really heavy snow falling in northwestern Washington there. Really heavy snow. Looks like some heavy wet snow. And here's the U.S. water vapor map to give you an idea of what's going on when the Doppler radar doesn't give you enough information. And let's check out this convergence zone here over southern Colorado. As we see this as a constant zone of convergence, where the Hall currents take over the atmosphere and cause people to be very confused about how atmospheric physics works. Anyway, there's that convergence zone, and we've got really two levels here. We've got moist air aloft, and there's a bit of a pressure inversion happening there, undoubtedly. And it should be a good day to see some interesting cloud formations. If you're located especially in southeast Colorado, shout out to Anomalous Howard. How is your project going? Please leave a comment. By the way, please take a moment to press like and subscribe on YouTube, as we can't even seem to get to 1,500 subscribers for some reason. In any case, thanks, Smash Team. Stay tuned for a bonus segment or two. By the way, if you haven't been to smashomash.com/forum yet, check it out. We've just started putting up direct links to cosmic ray sites. That's the latest post, as far as I know. And we're up to 50 members now, so thanks everybody for checking that out. Let's look at the 171 angstroms view and then call this a day. And there's the local yellow dwarf on 171 angstroms. And we're looking at the 48-hour view here. Looks like a little bit of filamentary activity kicked up here around this active plage, and then probably collapsed back down right there, as we don't see any Earth-facing coronal mass ejections. Anyway, we are out, folks. Thanks again for tuning into the Daily Space Weather. Stay tuned for another video, at least one more coming today, as there is a lot of other stuff to talk about. Remember to stare at the sun and not to drink, and if you do, don't drive. And since it'll never be now again, may that solar wind be at your back and that atherosclerosis absent from your veins.